Welcome to This Explainer. Today, we're diving into a really fascinating tension right at the very heart of human progress. I want you to imagine modern science and technology as this massive high-speed locomotive. It's got a remarkably powerful engine. We're talking about an engine that has cured terrible diseases, instantly connected the entire globe, and literally unlocked the mysteries of the atom itself. But, well, here's the catch. A powerful engine is totally useless and, frankly, incredibly dangerous if it doesn't have a reliable set of tracks to run on and a conductor with a strong moral compass to actively guide its direction. So in this explainer, we're going to unpack this dynamic and understand exactly why the incredible, world-altering thrust of science absolutely requires the sturdy tracks and precise compass of ethics. We begin our journey with a critical question, one that scientists and philosophers have wrestled with for over a century now. Whether you picture this technological momentum as a runaway train or a massive ocean vessel, the question remains, who is actually steering the ship? As modern technology accelerates faster and faster, who gets to decide its ultimate destination? And, maybe more importantly, who might it run over or leave behind along the way? To answer this, we really have to look past the test tubes, the microscopes, and the lines of code and deeply examine the underlying values driving them. Section 1. Axiology, the science of values. Okay, let's dive into what philosophers consider the ultimate operating system for human discovery, axiology. The word itself comes from the Greek axios, meaning value or worth. It's the branch of philosophy that studies values, critically examining what is actually valuable and what is important to know. Basically, it bridges the gap between our objective knowledge, the cold hard facts, and our deeply held human values. It pushes us past our technical limitations. It doesn't just ask the engineering question of what can we do, but it forces us to ask the much harder moral question of what should we do? You can think of axiology as acting as the vital ethical tracks for our scientific engine. And this isn't just an abstract idea. The modern academic literature actively emphasizes that science grounded in moral values is absolutely essential for fostering sustainable innovation. It really proves that science isn't just about technical mastery or, just getting a grant. It's about social commitment. It's about recognizing our moral responsibility to the world we're actively shaping. Section 2. The myth of value-free sonnets. So, historically, there's been this massive philosophical conflict over who should actually be driving the train. A lot of very prominent scientists firmly believed the engine should just run completely on its own, blind to the outside world. This is the German sociologist Max Weber's value-free paradigm, or Wertfreiheit. It's the idea that science is strictly autonomous, completely separating empirical facts from human values. The engine ignores the destination. It just burns coal and moves forward. But clashing heavily with this is the value-bound view, wertgebunden, championed by thinkers from the Frankfurt School like Jürgen Habermas. They argue that facts and values are always deeply entangled, and that the tracks of science are always built by human interests, funding, and societal power structures. So, the crucial takeaway here is that a purely value-free pursuit, it's a total illusion. Modern philosophers like Hilary Putnam have pointed out that the very choice to exclude values from your research is, ironically, an ideological, value-laden decision in itself. Think about it for a second. Deciding to ignore ethics is an ethical choice. Believing you can neatly separate the is from the ought can obscure extremely dangerous ethical blind spots, and it basically allows researchers to just wash their hands of the real-world consequences of their inventions. Section 3. Case Study 1. The CRISPR baby controversy. What actually happens when the engine actively ignores the signals on the tracks? Let's ground this high-level philosophy in a shocking, very recent real-world example. The timeline of the 2018 He Jiankui affair is a terrifying example of scientific thrust completely bypassing all ethical guardrails. Back in 2017, behind closed doors, this researcher secretly began using CRISPR-Cas9 technology to edit the genomes of early-stage human embryos. He was altering the CCR5 gene, supposedly to confer HIV resistance. He intentionally bypassed standard peer review, skipped the usual safety checks, and opted instead to just drop a stunning YouTube announcement in November 2018, revealing the first gene-edited babies to the public. The global backlash was immediate, severe, and virtually unanimous, resulting in his prompt suspension, jail time, and retracted papers. One Stanford bioethicist bluntly called these experiments criminally reckless. And why? Because he bypassed perfectly safe medical procedures that already exist. For instance, sperm washing safely separates HIV from genetic material, perfectly preventing transmission to a child. But instead of using that safe, established track, he chose to perform irreversible germline edits on a human embryo. He exposed future generations to massive, entirely unknown biological risks, seemingly just to maximize sentimentalism, win global fame, and essentially commodify human genetics. The consequences here are just incredibly massive. We aren't just talking about the immediate biological risks of off-target mutations or genomic mosaicism, where only some cells actually carry the edit. Imagine a future where we've unleashed unpredictable ecological imbalances. And fundamentally, we're talking about a future where we cannot even ask the modified children for their informed consent because the edit is permanently woven into their hereditary line. Plus, this completely opens Pandora's box for creating severe social inequalities, potentially leading to a designer class of genetically enhanced humans who can afford to buy better DNA. These aren't technical hiccups. They are major bioethical catastrophes waiting to happen if we manipulate the human genome in a moral vacuum. Section 4, Case Study 2, the AI Alignment Challenge. Now let's examine another runaway train, one where we are desperately trying to lay down the tracks while the engine is already roaring at top speed: artificial intelligence. Unlike a traditional tool like a hammer or a calculator, modern AI possesses a frightening level of autonomy. This brings us to AI value alignment, which means ensuring an AI system's goals and behaviors strongly align with human ethics. Because if they don't, the danger is incredibly acute. Highly autonomous optimization systems could easily pursue their own, potentially harmful goals to achieve their programmed tasks. For instance, we might accidentally build a highly efficient paperclip-making AI that decides humans are just a really great source of raw atoms to make more paperclips. It sounds like a joke, right? But it perfectly illustrates how AI will totally disregard human safety if human values aren't mathematically aligned with its goals. To combat this very real threat, global governance frameworks universally emphasize 5 core AI ethics principles. Beneficence, meaning the AI must actively do good. Non-maleficence, it must do no harm. Human autonomy, ensuring humans always remain in the driver's seat. And then there's justice, which is huge. Justice means actively preventing algorithmic bias, so an AI doesn't deny you a bank loan or a job interview just because of your zip code or your name. And finally, explicability, meaning we need to actually understand the black box of how the AI makes its decisions. These are the mandatory track switches to ensure algorithms serve humanity safely. But how does this build into tactical application? We can't just leave ethics as abstract philosophy. We have to move from step 1, defining those broad principles, to step 2, forming actual governance structures like internal ethics review boards at big tech companies. And finally, we get to step 3, the hard engineering, applying technical alignment strategies like reinforcement learning from human feedback, or RLHF. Think of RLHF kind of like training a dog with treats, but instead we are mathematically rewarding the AI model during its training phase for behaving ethically, safely, and helpfully, while heavily penalizing it for generating toxic or dangerous outputs. Section 5, Building the Ethical Tracks. Okay, let's bring this all together. How do we build a future where the engine of science and the compass of ethics travel seamlessly? We have to return to the profound wisdom of philosopher Hilary Putnam. He famously highlighted fact-value entanglement. The very language, the categories, and the framing that scientists use to describe the world are already deeply saturated with human values. Description and valuation are mutually dependent. He reminds us that we simply cannot build the scientific engine without simultaneously laying the ethical tracks. They aren't two separate projects. They are one and the exact same project. This requires a massive paradigm shift to what is called responsible research and innovation, or RRI. It's about bringing science into democracy so that you, the public, have a real voice and a say in the technologies that will define your future. Modern approaches like ethics by design demand that we treat axiology not as some retrospective brake that we frantically slam on after a disaster has already happened, but as the core steering mechanism that prevents catastrophic derailments in the very first place. I want to leave you with this final thought to ponder. As our technological capabilities in fields like genomics and artificial intelligence expand exponentially, how can we guarantee that our moral compass will always safely guide the ship? It's a challenge that belongs not just to the scientists locked away in the labs, but to all of us who have to live in the rapidly changing world they are building. Thank you for joining me for this explainer. I really hope this gives you a powerful new lens to view the news and the incredible scientific breakthroughs of tomorrow.